Hey there, everybody. I am Storm Team Meteorologist Kate Thornton from News Channel 9. I am the weekday morning meteorologist here at the station, and I'm the person this time of the year will tell you if you're going to have a snow day or not, if we have some snow moving in, like a little bit this morning, but so far we haven't really seen much snow around. So I want to tell you all about weather and meteorology and how you can become a meteorologist if you want to. So the number one question I get, well, what is the difference between a meteorologist and a weather forecaster? Well, it's one main thing that sets us apart: a 4-year college degree. That's how you can tell by how someone is titled, if they actually have that college degree or not. So I have my meteorology degree from SUNY Albany, graduated back in the mid-2000s. And for anyone who maybe hasn't graduated with that meteorology degree, then they're labeled as a weather forecaster or a weather anchor. Those are the people that you see on TV. But the meteorologists, they have that degree. Now, there's many other types of meteorologists. Obviously, there's the broadcast meteorologists like me, but there's others that work at the National Weather Service. Our local office is based out of Binghamton, and they're the ones that actually send out those alerts that you see at the bottom of your screen when you hear that mer, 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 and you see maybe the severe thunderstorm warnings or flood warnings or anything. Those are the folks that do all that. And then you actually have meteorologists that work for the government. You know, our military need to know what they're up against weather-wise, whether they have a mission to complete or anything. Weather played a major role in the meteorologists back in World War II in those battles. So you'll have anyone from the Air Force to the Naval Academy as well. And then you also have the private sector. So you have private companies that are forecasting for like Yankee Stadium or any big NFL stadiums, or even for places like Target. So they know to send over some umbrellas to areas that are maybe getting a lot of rain. So those are different kinds of meteorologists. And of course, you need to go to school for meteorology and weather, and you have to love math and science because there's a lot of it in there. But you know, I always encourage kids, even if you're not the best at the math and science, I certainly wasn't. I was not the top student in math. All you do is work hard and do your best, and as long as you have a love for it, then you can do anything that you can. So I've been here at News Channel 9 for almost 8 years now. Yeah, for coming up on 8 years. I've been doing this morning shift here for 5.5 years. And another big question I get is, well, what time do you wake up in the morning? When you're working the morning shift like I do, I'm up at 2 o'clock in the morning because we're on air at 4:30 in the morning. Well, why do I have to be in here so early? Why do I have to be here at 3 a.m.? Because I have to forecast. That's another question I always get. Well, do you do your own forecasting, or do you just take off of a website or anything? No, we do our own forecasting. And there's a few things that we look at, and I'm going to show you that now. This right here, what's behind me, is live Doppler 9. You hear us talk about it all the time. A radar is this large, almost looks like a massive golf ball. I mean massive, like as big as a building. And if you're ever down in the Pompey area, especially over near like Heritage Hill, you'll see it up in the sky, our own personal radar. And what that does, it sends out a beam that you can't physically see, but it sends out a beam and it just kind of scans the sky for any rain or snow, like in the wintertime, which is what we see here on our radar. So this is a loop. You may notice how there's kind of like a hole right there. That's where the radar is, and it's sending out its beam, scanning around. Now, depending on how light or heavy the precipitation is, it's all on a color code. So if this were all rain, and if it were really heavy rain, it would show up as like the yellows and the oranges and the reds. So that's something we keep an eye on for some very heavy rain. And then for heavy snowfall, it starts to turn darker purple, but even into the yellows. And so that's when we have the real low visibility and the real heavy snow. So we look at the radar, but we also look at the satellite. So this is kind of a wider view, and you may be able to see here some cloud cover. And so that's what the satellites are picking up. They'll pick up on water vapor in the air. Water vapor, of course, is our clouds. And so that's how we can tell what is going on in the big picture. We see this line right here going across Syracuse. That's telling us there's a cold front, because we know that the temperatures are colder back behind this cold front. What drives our weather? Well, the sun. The sun drives our weather. Weather is the difference of temperatures and how our air reacts to them. And it's all about the jet stream, okay? The jet stream is a current of fast-moving air in the upper levels of the atmosphere, and the wind speeds, I mean, they can reach over 20, 30, 50, 60 miles per hour. It has been super windy lately because this time of the year in the winter time, the jet stream is very close to us. So the closer we are to the jet stream, the windier it can be, which is why winter time can typically be pretty breezy for us. And it also kind of separates where the colder air and the warmer air is. So they're caused by temperature and pressure differences around the entire world and will act as a boundary between the colder air up in the poles and the warmer air down at the equator. Now, depending on the time of the year, jet stream is farther north or warmer in the summertime, and in the wintertime, the jet stream will be farther south, bringing in that colder air, which is why we are so cold in the wintertime. And the jet stream will move areas of low pressure over the entire globe, and that's how we get weather. And that's where we have highs and lows. High pressure, low pressure. I always think of L for lousy and H for happy. High pressure is air that's coming down. It's colder air. Remember, colder air is heavier than warmer air. If something's heavier, it's going to go down, right? And warmer air goes up. So when you have air coming down, you can't have clouds because are the clouds up in the sky or at the ground? Well, fog is at the ground, but otherwise, we have that colder air coming down. It moves out, separates, and that's where we get really nice sunny days. Now, on the flip side, we have L, lousy weather, low pressure. This is where we get our storms because we have warmer air. Remember, warmer air is lighter, so it rises. And when that happens, that air turns cooler, it latches onto water vapor and turns into clouds. And eventually, there's so much water vapor in the clouds, it gets too heavy, it falls to the ground as rain. Or in the wintertime, if it's cold enough, it falls to the ground as snow. So we talk about warm fronts, cold fronts. You always have those around low pressures, not highs, but lows. In between, you'll hear us talking about what's called the warm sector. In between our warm front and the cold front, this is where the warmest part of the air is going to be. Back behind the cold front, colder air is coming in. So that's why sometimes we'll have days where it's super warm in the morning, but then by the time you get home from school, it's much colder. That's because a cold front comes through. And the opposite will happen with a warm front. So the colder air will push in behind this, and then with that air coming up, that's where you have thunderstorms and some rain. But more so with the colder air, because with thunderstorms, hot air and cold air, they do not like to be next to each other. They kind of fight it out, which is why we tend to have more severe weather along cold fronts, because you just have more what's called instability. And that creates thunderstorms and lightning, or in the wintertime, some stronger snowstorms as well. So we always keep an eye on that. Thunder and lightning. Well, I'm sure many of you know that when you hear thunder, or when you see lightning, then you count. 1 Mississippi, 2 Mississippi, 3 Mississippi. You get to 5 seconds, and then when you hear that thunder, that means that it's 1 mile away, which is why we always say, when thunder roars, head indoors. You never want to be outside during a thunderstorm because lightning is very, very dangerous, okay? You always want to go indoors or in a car, never under a tree, right? We never do that, okay? And there's no such thing as heat lightning either, okay? That's a big myth as well. Heat lightning, it's really just a thunderstorm way off in the distance that you're seeing, and that's really about it. So when thunder roars, head indoors. Always remember that. Tornadoes. Now, luckily, we really don't get a lot of them, but recently, these past couple of years, we've been seeing more and more tornado warnings issued, and we have confirmed EF0, 1s and even 2s, but even some microbursts or the straight line winds. So a tornado will form. You have surface winds going in one direction, and the upper level winds are going in a different direction, and it creates this rotating column of air. And eventually, this column will turn into an updraft. And it will continue to turn to a point where that air is going up and down back behind this and will create what's called a wall cloud and eventually a funnel cloud. So we have a lot of opposing air going around and around and around. If you ever have the trick with the 2 soda bottles and you can attach them and have the water go on, you shake it, you see that tornado? That's a fun experiment to do. And so if it doesn't touch the ground, it's just a funnel cloud, but if it touches the ground, it's a tornado. And if it's over water, it's a water spout. Where to go during a tornado warning? This is also very important. Again, we don't get a lot of tornadoes around here, but it's always good to know what to do. You always want to go to the lowest level of your home in the most interior room, like a hallway, a closet, a stairwell. or even the bathroom. The bathtub is a good spot for it, but that's if you don't have a basement, but the basement is the best spot for it. And we categorize it by the enhanced Vegeta scale. So it goes from an EF0 all the way to an EF5. The devastating tornadoes that happened in Kentucky a few months ago, that was a very high EF4, and so that can cause extensive damage. Luckily here we don't usually get much more than an EF1. Also flooding, we get a lot of that around here. We have been super rainy these last few years, so you always turn around, don't drown. 1 foot of water will float away vehicles, and 2 feet of rushing water can carry most vehicles and SUVs out of the way. It does not take much to knock you off your feet. Also, you don't know what's in the water. It's really murky, it's really dirty with a whole bunch of nasty stuff. So just you want to avoid it as much as possible. And hail, this is one of my pet peeves, okay? When it's winter time and you're seeing ice falling from the sky, that's not hail, that's sleet. But in the summertime with thunderstorms, it is hail. So you have these frozen water droplets that are suspended in the clouds, and it keeps falling and rising, and keeps growing and growing and growing in hail size to a point where it is too heavy to stay up in the clouds, and it falls to the ground as hail. It's pretty cool. Not a lot of thunderstorms do that, but when we do get them, it is pretty neat. And then hurricanes, these are my personal favorites. So they form off the coast of Africa and they travel across the ocean, and it hits very, very warm bodies of water. Hurricanes need warm water, but also not a lot of wind shear. We talked about wind shear with tornadoes. Tornadoes love wind shear. That's how they get their rotation. Hurricanes, not so much. You need to have bodies of water over 79 degrees, but also not a lot of wind shear or conflicting wind direction. It likes a nice smooth sailing, okay? So that's something that we keep an eye on. And with this, you may have heard the Saffir-Simpson scale, category 1, 2, 3, 4, 5, or tropical storm, and that's exactly what we have, and a lot of that is due to wind speeds. Category 5, 157 mile per hour wind gusts, and we've had a couple of those in the last few years. And then for us here, this is what we deal with a lot. How does different precipitation form? It's all about the air temperature here at the surface and all the way up at the cloud deck. So this time of the year, things can get a little tricky between snow and rain, or a little bit of both. So you get rain. First off, everything starts as a snowflake up in the cloud, no matter what. Well, in the summertime, mostly rain, but starts as a snowflake. As it falls to the ground, it will hit warm air above freezing, and it will turn into a raindrop. It will melt and turn into a raindrop. Now, as it hits warm air, but maybe it's at the freezing mark at the surface, it will refreeze as freezing rain. But maybe you have a little bit of warm air. Now, it's already melted, but then it hits some more colder air. It can't turn back to a snowflake, but it will refreeze as sleet, which is why I say in the wintertime it's sleet and not hail. And then when it's cold, below freezing from the cloud to the surface, it is snow, and something we get a lot of here in central New York, and why we are always so snowy. Yeah, we get some snowstorms, but a lot of it is from lake effect because of our proximity to Lake Ontario and Lake Erie. So this is Lake Ontario, warm water, and then we have colder air inland. You have that cold air coming in from Canada blowing over the lake. You have the moisture, that warm air. Remember, warm air rises. It rises up. It hits that cold air, and it turns into snow, which is why the Tug Hill area gets so much snow every single year, because it's obviously colder the higher up in elevation you go. So that's why we call it lake effect, and it can be super localized, where you can have snow like 10 inches in one town. You go down the road 2 miles, and there will be nothing. So we take a look at all that. We look at our weather models, and we put our forecast together, and then it's showtime. We do our weather forecast, obviously, here on the pod. This is the studio. I'll show you real quick. This is always the fun part, is the weather wall. People love seeing this. So we'll do our forecast right over here in front of our green wall. And people will ask, well, how do you know what you're looking at? Do you see right here? That's a camera, and I can actually see myself. I can see myself right now looking at you, and this is what it looks like. It looks like I'm standing in front of the lake effect, but I'm really not. This is all just one green screen, which is why I can't wear green, which makes St. Patrick's Day not very fun. Because if I did, then I'd turn into the snow. You wouldn't be able to see me. And I can also see myself. There's a monitor right there and right there. So when you see us turn to the side, we can actually look to see where we are and what we are doing. It's TV magic. All right, well, thank you so much for having me, everybody. I hope everyone has a safe couple of days coming up, and also staying safe as we're heading into severe weather season this spring and this summer. Thank you so much for having me. I'm Storm Team Meteorologist Kate Thornton. You can follow me on Instagram at Hurricane Chippy, on Facebook, Kate Thornton NC9, and on Twitter at Kate Thornton NC9 there. Thank you so much.